So I started my equation with taking these variables and throwing that into my third kinematic equation, and using that to solve for my acceleration over flat ground. And then I drew my free body diagram, and in the y direction, since the acceleration in the y direction is 0, I said that the normal force has to be equal to mg, and we don't know m, so I was a little concerned at first, but then the only force in the x direction is our braking force. That's our frictional force, which is mu n, and again I was like, we don't know m, we don't know mu, but then the m's start to cancel, and we're like, okay, we'll be fine. So then we're left with negative mu g equals a, and I just divided that negative g over, and I took the a that we just found in this part and divided it by g, and that would be our coefficient of friction. Then we put it over in flat ground, or then we put it over on an inclined plane. And our inclined plane here, this distance here, this x direction, is mg sine theta, and this distance is mg, oh no, what's that? Stop. Mg cosine theta. So, when we do our x, oh, and then this blue over here is saying that this is the x and this is the y. So in the x, or in the y direction, we just have normal force going up, and then this mg cosine going down. So then we know, now we have solved for n, which is going to be important because we're going to be using mu again. So then this frictional force is coming down. Frictional force is coming down, and, key thing here, and mg sine is coming down. So again, frictional force going to the left, and the x component of the gravitational force coming down. And then here we go canceling. Or so, n is, like we found over here, n is mg cosine, so here's mg cosine. And then here we go canceling. We've got, these are just a bunch of constants. So at that point, we can solve for our new, acceleration. And then once we have our new acceleration, we already have v final, v initial, and now we have our new acceleration. So we can solve for our new displacement, which is I think that's in meters, 34.8 meters.